Hello guys, my name is Michael, and in this video we are going to set very important compiler flags which you can use them and which can help you to catch a lot of mistakes and errors which you can code them in your code, in your application, so that makes your life easier without having to debug all bunch of codes which you are creating with some buggy codes inside it. So that being said, for this we are going to see now a list which I strongly suggest you that you are working with them. I'm using the C18, which is the latch standard from what I know, the pedantic, and of course I'm turning them to errors, the warning all, warning extra, warning error, and so on. Just refer to the GCC documentation and you're going to see which kind of exactly things catch these flags here. There are a lot of them, as you can see, and we are using them all the time. Optimization level is not so important, but if you are a beginner I'm suggesting you to use it to 3, but you can also use it to 0. And of course the -G for the symbols if you want to debug it later in your GDB debugger, because it helps you to see exactly what kind of problems you have when you debug your codes. So that being said, these kind of things you have to set them to your compiler. For this you need to go to settings, compiler, other compiler options right here, and then here you can put all your flags. I have them here, all of them, so I'm just going to copy this part right here, which are all those above, and I'm going to throw it here. Now I can press OK. I rebuild, though, like I said, every time you make some changes in settings, just hit the rebuild project before you do something change, and now takes place. Watch, now we cannot anymore compile our program, and it should be like that. I mean, why would you create a main which has no parameters? Because the standard says it should be at least void, or it should be at least RGC and RGV, isn't? Yeah, of course, char, which is not important now. What kind of what I'm going to prototype. Okay, so int RGC and char RGV. So why would you let main to be empty like this? You cannot. You see, it is based on the standard, so it follows the standard. This means the function declaration isn't the prototype. So this is the old style definition, as you can see here. So that being said, you need at least one of them. Of course, if you are not working with arguments, this one is also bad. Watch, I'm going to compile it and run, and it says unused parameter RGC and RGV. Of course, because they're not used. So why should I work with this? I see a lot of people every day on Stack on the floor or whatever where I'm watching them, and all the time they are providing answers or questions where they are putting this main signature like this one, and then they are working with codes where those two parameters are not used. So this means it's wrong. It should not be there. It should be void. Now let us compile and run the program, and as you can see, it works fine. Another good thing about this, it is the function definition and declaration, which helps you all the time. If you create a function like I don't know, int ret, int min, or something like this, int I, int yeah, whatever, int a, int b, and then you're going to say return let's say a, which is less than b, then a else b. Of course it is in another way, we need to do it like this. And now when we are working with this function, we are trying to compile it. Now says no previous prototype for min, so this means we need to share, we need to provide a prototype. So once that you provide it, like me now right here, then no mistakes are available. Now we can compile it again, and once that we compile it, we can run it and we can see that it works fine. And also we can now move, because we don't need it anymore, we can move it down here and we can compile it and run it. You see, works fine. Of course we are not using this function, but I wanted to show you what's the story with this. So if I'm now removing its declaration, you get an error where it says no previous prototype for min. So this means if you try to do something here like hello world, I don't know, let's put something here to calculate our, let's say min 5 3. So we are calling basically our min function to see which one it is, the smaller one. And when we are compiling, it says implicit declaration of the function min. Did you mean main? Of course, you see, you get a help. This is another feature of the GCC 9. You will see a lot of helps which you get where compiler try to catch your error. Okay, in this moment when the compiler compiles, it compiles from top to bottom, so it cannot see your function here because you didn't declare it, you are using it. So because you are using this function, it goes right here, and then later it's coming, you see here, and says you have no previous prototype for the min. So this means to make it work, you need to declare it. So once that I declare it here, now our program should work fine and says which is the minimum, which is 3 in our case. But this is not the object of our tutorial. I wanted to show you the benefits of using GCC 9 and of course those flags. There are things like I don't know, let's see, for example, yes, the return 0, you don't need it. Starting with C99, it is main implicit returns. It is how can I say it? It is implicit in its return. So basically, when you set main to int, you have the return already inside. So that being said, you can compile it, run it, and works perfectly, and it should work. You don't need to return 0 here. But watch what happens if you are using wrong things like void main. There is no such thing like void. If you are learning using, or you think you need to use void, it's wrong and it's old and it's bad. Even if you are working with, I don't know, it's just remember, the only standard it is int main, void int main, and those two arguments. There is no void main, not in the standard which we are actually using, and this is a very old standard. So when I compile it now, it says error, return type of main is not int. You see, it catch it, and it should catch it because it should be int and not main. When you type something like, for example, char name, and then you say Michael, for example, when you try to print hello name, okay, name, let me drop this part here because we don't need it. Okay, let me show you something. I try to compile it, and says initialization discard the constant quality. So basically, never, and I repeat, never create a char pointer which points to a literal string using only char. You should use the const qualifier, and of course this constant qualifier you already get informed from your compiler, so that means you cannot compile it if you don't put it. So this is another thing which a lot of people they used to not use it. Let me delete for a second all those flags. So I'm just drop them, I hit OK, I rebuild, and then I hit build and run and see what happens. You see, works fine. So you said, what the heck, why do I need that cost qualifier? Well, let me show you something. Let me show you something very interesting. I'm not sure if with GCC 9 is working because it's too clever in this version, but I will try. Watch. Name 0. I will change the first letter of the name 0 to T. Okay? Let us compile and run. I'm using so long time that I'm not sure what happened now, but I'm sure earlier when you did something like that, you got all the time a segmentation fault, which in my opinion is bad. You should not get a segmentation fault, you should get something else, and I will show you what. So let me compile and run and see what happens. It compiles fine, and segmentation fault. You see? Now you have a problem. Now you have to go back to your code. You have to go back to your code, I repeat it, and see where the problem is. If you have 2000 lines, then you have the second problem. So this means have fun with your debugger. So why would you create some mistakes when you can just use a clever flag, which is right here, this one, Write-strings. Let me show you something. I'm going to use C8 thing with this oh no, let me see what happens if I'm just using this flag. This flag, it does the job for you. Watch. Settings, compiler, the compiler option, and now I'm putting the write string right here. Okay, now I'm going to rebuild it. Watch, it says initialization discards constant qualifier from important type. You see? So this one catch your mistake right here, so that when you try to compile it, it doesn't compile. I mean, it should be there and should warn you. But me, because I choose only the warning and I ignore it, you saw that he let me to compile it. Watch again. I still can't compile it, even if I put a flag. Why? Well, because I didn't treat this thing like an error. That's the reason why you have these warnings. This one show them all, so I'm copying only this one. I'm going back now to the settings, compiler, other compiler, and then I'm going to put it in the front here. I hit OK, rebuild, and now it says again I'm going to build and run, and of course segmentation fault. And this happens, oops, sorry, this happens all the time just because you don't treat it as an error, like using this one, W error. If you use this flag, for example, let me go back to our project, settings, compiler, other compiler option, and now when I'm going to treat all kind of warnings and the error also, now watch. When I try to compile it, you see it's working because I told you before you do something, after you make some changes here, rebuild your project. And now it says initialization discards const qualifier from point and target type. So this means I need to use that const. If I try to build it again, it will say all the time, so you cannot build and run this program. You need to provide this const. Once that you provide it, it says a segment of read-only location name. You see, now it catch the problem, and you know exactly where the problem is. So having this problem catched, you know exactly you need to fix it, and by doing this you don't need to debug your program to find where the segmentation fault take place. Anyway, a problem like this, which is so small, even this one is wrong, but you cannot make changes, because if it's not wrong, but even if I remove this one here and you have just a small problem like this, it is still not right, even if it's kind of right. This means to have it right, you need another const here, which means you are saying now, I'm not going to modify this string where I'm pointing, and I'm not going to modify the pointer itself too. So we are not going to modify the pointer and not the pointer value where the pointer points to. So basically this is the right use of const qualifier in this case, where as you can see, I'm just printing it, I'm just using it for printing. So just for something like this, I'm strongly suggest you to use const char star and const again, and then the name of the pointer, and then when you have it, you're 100% sure and safe that nothing happens. Of course, if you try to move now the pointer where it can be accidentally, I don't know, let's say const char pointer, and then we are going to say name points this time to ptr, and we're going to compile it, and says a segment of read-only malware. See, it's not working, you cannot. And this is good if you don't want to change your name to point to something else. I want to point only to this one, so why should I point it here? This means I made a mistake in my code, I want to do something and accidentally I made something wrong, so I use the name to point this time to this pointer, and this is wrong. So that being said, if you really want to point it, then you just need to remove the const here, and once that you remove it, you see now it is not you see you get the second problem, and the second problem is the last thing which I'm going to talk with you. Always, and I mean always, even if you do the code right in the next line, always initialize your pointers with null, always, because if you do this, then you can check all the time your pointer if it points to something or if it's null. So this means now I can basically do the job. It points to pointer, the name points to ptr, which is null, and of course I can check it. If name it's equal to null, then print f bingo, we have a null pointer. Okay, pointer. So let's see, let's compile it and run it, and says bingo, we have a null pointer. What do you think it happens if you try to set the pointer to not point to null? It is hard in this example because the compiler won't let me. Let me remove again all these. Okay, now it looks creepy. Let's go back. Settings, compiler. Okay, I'm going to remove everything here. I'm going to rebuild it. And now I remove the null here, and I will compile it and run it. Watch, it compiles fine and runs fine and says bingo, we have a null pointer. This is undefined behavior. Don't rely just because your compiler is smart enough to set your pointer to null, like in this case. It's just an exception because this pointer is not initialized to nothing, so you cannot check against null. This is wrong. Me, if I'm trying now, I'm not sure, let's see, let's go back to compiler and let's change this one to level optimization, which is let's put in 3. Okay, I'm going to ignore for a second this part. Okay, it catching you, so it is bad. Maybe if I void function const char, char pointer, and then we are going to make this check right here. Let's see if we get a better result. Okay, so now we are going to let it like this, and we are going to say we are going to pass inside this function our name this time. So basically we have here, we create a pointer and we are pointing to this literal string Michael, and then we create another pointer. We are pointing the name pointer now to this pointer, which it is not initialized, and then we are passing the name pointer here, which is now pointing to nothing, to we are passing to this function, and inside this function we are going to check if this pointer it is null. You see, we have a null pointer. This is because the compiler is clever enough to catch it. I don't know, let me try to make some changes if I can, because I think it already freezed my code block as I can see. Yeah, it freezed. No, whatever. Okay, this is not the point. The point is always, and I repeat, always use enough flags which you can to catch your warnings and everything, and after you are sure that everything should be fine, then you can remove them, and after you remove them you can then basically see where the problem is. You see, me after I compile it, it won't let me, because it says ptr it's uninitialized in this function. So basically when I'm passing name here, it is uninitialized because we are initializing the name with a pointer which pointed to nothing. Let me go back to this part here. It's strange again. Compiler, come on. I'm running in VirtualBox this Linux version because I didn't want to install a fresh copy. So it is normal that has this kind of problems. You see, it doesn't update its settings, so I need to wait a little bit until it works. Yeah, now it's working fine. And now let me put again this one 0. See what happens. Rebuild and try to compile it, and as you can see, compiles and fine, and still says we have a null pointer. Never, and I repeat, never rely on the fact that your pointer it is pointing to null, it is 0. No, your pointer at this moment it's pointing to something. So basically you can do a lot of mistakes by working with a pointer like this one, in this case right now, because it's pointing to nothing. That being said, always when you declare a pointer, even if next line you are pointing another pointer to this one, or you are pointing your pointer to, like for example, even if you do something like this, point ptr, now you are seeing the name to it. Even if you do something like this, don't let you believe that you are clever enough to not make mistake, because later, after you make some changes to your code and so on, and then to decide you know me, after you don't have this null here, and you say, no, you see, no, I don't need this part here, I don't need it because I don't need my pointer to point right there, and then you pass your pointer to a function. bam, it will pass here, it will catch you, and then you will suffer a lot of work, trust me, and you will have a lot of debug things. But this, like I said, will never happen if you are working with all kind of possible compiler flags. Like me, I'm passing them right now in here. So now I press OK, I build it, I rebuild it, and now it is not working. Just for the first problem, it's our function, has no prototype, so I will provide one. Once that we have it, we compile it and run it again, and then okay, come the next one, because those things should not be here. Okay, and now I compile it again, and once the compile says PTR, it's used uninitialized in this function, so basically you are safe. Okay, so that being said, thank you guys for watching. If you like it, please subscribe, share with your friends and neighbors, and until next time, see you guys.